Abdominal fat, particularly the deep visceral fat that surrounds your internal organs, is not just a cosmetic concern but a significant health risk. This specific type of fat plays a crucial role in developing insulin resistance, a precursor to type 2 diabetes and other metabolic disorders. Unlike subcutaneous fat that sits just beneath your skin, visceral fat in your abdomen is metabolically active tissue. It functions almost like an endocrine organ, releasing various substances that affect how your body processes and responds to insulin. When we consume food, our pancreas releases insulin to help cells absorb glucose from the bloodstream. In a healthy system, cells readily respond to insulin by opening channels that allow glucose to enter. However, abdominal fat disrupts this delicate process through several mechanisms. First, visceral fat cells release pro-inflammatory cytokines such as tumor necrosis factor alpha and interleukin-6. These inflammatory molecules directly interfere with insulin signaling pathways in cells throughout your body. They block the insulin receptors and disrupt the internal cellular machinery that normally responds to insulin, making cells less sensitive to insulin's effects. Abdominal fat also releases higher amounts of free fatty acids directly into the portal vein, which leads straight to the liver. This flood of fatty acids forces the liver to produce more glucose while becoming resistant to insulin itself. The liver then releases more glucose into the bloodstream, creating a vicious cycle that worsens insulin resistance. Another critical factor is the production of adipokines, which are hormones released by fat tissue. Visceral fat produces less adiponectin, a beneficial hormone that increases insulin sensitivity and more resistant, and retinol-binding protein 4, which promote insulin resistance. This imbalance in adipokine production significantly contributes to whole-body insulin resistance. The location of visceral fat is particularly problematic because of its proximity to vital organs. Fat surrounding the pancreas can directly impair beta cell function, reducing insulin production and further compromising glucose regulation. Visceral fat cells also have more glucocorticoid receptors than subcutaneous fat cells. This means they're more sensitive to cortisol, the stress hormone, which increases fat storage in the abdominal area and promotes insulin resistance through multiple pathways. Additionally, abdominal fat accumulation is associated with increased oxidative stress, which damages cellular components and further impairs insulin signaling. The combination of inflammation, oxidative stress, and altered hormone production creates the perfect storm for insulin resistance. Reducing abdominal fat through diet, exercise, and stress management can significantly improve insulin sensitivity. Even modest weight loss targeting visceral fat can lead to substantial improvements in metabolic health, demonstrating the powerful connection between abdominal fat and insulin function. Understanding this relationship helps explain why waist circumference is often a better predictor of metabolic disease risk than overall body weight, and why targeted approaches to reduce visceral fat are so important for preventing and managing conditions like diabetes and metabolic syndrome.